So today we'll take up the 27th session on relative velocity. This will be in continuation of the 21st video, in which the relative acceleration between two moving points was defined. So in this 22nd video we will discuss the calculation of relative acceleration between two moving points, the magnitudes and directions of whose accelerations are given. Okay. So this is the, suppose F is some reference frame. Okay. P1 and P2 are two moving points. P1 and P2 are two moving points as seen from frame F. Acceleration of P1 with respect to frame F at time t is a1f. Acceleration of P2 with respect to frame F at time t is a2f. So let theta be the angle between a2f and a1f. Angle between a2f and a1f. From this diagram, theta, if we parallel shift this here, if we bring this one here, parallel shifting, okay. So theta will be shown in the diagram in this way. This a1f I draw here, a2f I shift parallelly here. This is the angle between these two vectors theta. Okay. Now we know that relative acceleration of P2 with respect to P1 in frame F is nothing but a2f minus a1f. Now we just for the sake of simplifying the notation, we will denote this quantity by a relative, say. Okay. Say a P2 P1f will be denoted by a relative just for the sake of simplifying the notation. Fine. So this will mean that a relative is equal to a2f minus a1f. This is also known to be from the difference of theory of difference between two vectors. This is nothing but a2f plus minus of a1f. So a relative is equal to a2f plus minus of a1f. First of all, what we do, we calculate the magnitude of a relative. So magnitude of a relative from the theory of vector difference is nothing but this root under a1f square plus a2f square. I'll just write it once again. Okay, fine. a1f square plus a2f square minus 2a1f a2f into cos theta. This follows from the difference of the theory of difference in between two vectors, vector a minus vector b, vector a2f minus a1f. So this is the magnitude of a relative, and this is nothing but the magnitude of vector a p2 p1 slash f. So this is the basic formula. Okay. So one more thing we have to note down, that if you want to show this a relative in a diagram, acceleration of P2 with respect to P1 in frame F, then we reverse the direction of A1F minus A1F and add it vectorially to A2F. So two things are to be taken into account. First, if we want to find the relative acceleration of P2 with respect to P1 in frame F, we reverse the direction of A1F and add it vectorially to A2F. If we want to find the relative acceleration of P1 with respect to P2 in frame F, then we reverse a2f and add it vectorially to a2f. Okay, I'll just repeat it. If we want to find the relative acceleration of P2 with respect to P1 in frame F, we reverse a1f and add it vectorially to a2f. If we want to find the relative acceleration of P1 with respect to P2 in frame F, then we reverse a2f and add it vectorially to a1f. I've made it clear. Okay, just before this, if I wrongly uttered it, I have corrected it. Okay. That meaning that we have to reverse the acceleration of point with respect to which acceleration of some other point is to be found. For example, if you want to find the relative acceleration of P3 with respect to P2 in frame F, then we reverse A2F and add it vectorially to A3F. Then we get AP2, P3, P2F. Or suppose we want to find the relative acceleration of P1 with respect to P3 in frame F. Then we reverse A3F and add it vectorially to A1F. if we want to find the relative acceleration of P2 with respect to P4 in frame F, then we reverse A4F and add it vectorially to A2F. This point I think it is clear, okay. I might have wrongly uttered one dot just here, careless mistake, but I have made it clear, fine. So this point should be noted down. And once we have reversed, we have just follow the rules of vector addition. So this will take up just now. But before that, I will take a problem just to demonstrate this concept. Just to demonstrate the application of this formula. Fine. I will write this, okay. So I'll take up an example to demonstrate this use of this formula. Suppose instead of F we have ground frame. Instead of F we have ground frame, okay. So question is this. P1 and P2 are two moving points. P1 and P2 are two moving points with respect to ground, okay, and magnitudes of acceleration of P1 and P2 with respect to G meaning ground frame, at a given instant is equal to 4 meter per second square and 6 meter per second square respectively. These accelerations are with respect to ground frame, and theta is the angle between A1G and A2G. A1G meaning acceleration of P1 with respect to ground, and A2G meaning acceleration of P2 with respect to ground at the same instant t. So we have to find magnitude of A, P2, P1G when different values of theta are specified. When first theta is 0 degree, second theta is 60 degree, third theta is equal to 90 degree, fourth theta is equal to 120 degree, and fifth theta is equal to 180 degree. In all the 5 cases, we have to determine the magnitude of this relative acceleration vector. So we'll use the general formula, okay. A1G is equal to 4 meter per second square, A2G is equal to 6 meter per second square, fine. So what we'll do, we'll write down the general expression just now as we stated just now. So we'll say A, P2, P1G, this is just the magnitude of this vector which we have to find out. As discussed just now, this is equal to A P1G whole square. Sometimes I write A P1G, sometimes I write A1G. It should be clear for context. It means just the acceleration of P1 with respect to ground, okay. I write sometimes A P1G, sometimes A1G, so don't be confused with that, okay. Plus A P2G whole square minus 2A P1G A P2G into cos theta, okay. So we'll substitute each of these values in each of these 5 cases. Then we'll get A P2 P1G, fine. So for first case, so these terms are going to be common, so this will not calculate again, one time calculation. So this in all the 5 cases, A P1G, A P2G, they are same. magnitude wise, 4 meter per second square, 6 meter per second square. So this will write as 4 square plus 6 square minus 2 into 4 into 6 into cos theta. So this will become equal to root under 4 square becomes 16, 6 square becomes 36, 36 plus 16 becomes 52 minus 4, 6, 24 into 2, 48. So this we have calculated because this is common to all of these 5 values of theta. So just to avoid unnecessary time wastage, I have written this value. Okay. Now we put the values of theta in each of these in this case. Okay. First case, theta is 0 degree. In that case, A P2 P1 G becomes root under 52 minus 48 cos 0 degree. It is well known that cos 0 degree is equal to 1. So this becomes root under 52 minus 48. The root under 4 meaning 2 meter per second square. This is the answer to the first part of the question. Fine. Now second case, theta is given to be 60 degree. In this case again we have to determine AP2 P1G magnitude. Okay. So this will write as AP2 P1G is equal to root under 52 minus 48 cos 60 degree. Cos 60 degree becomes half by trigonometry. This becomes 52 minus 48 into half. This becomes root under 52 minus 24. That becomes 28. 28. So this becomes 2 root 7 meter per second square. This is the answer to the second part of the question for the value of theta equal to 60 degree. Okay, fine. I'll rub this portion. Okay. Now we take the third value of theta, 90 degree. So for theta equal to 90 degree, magnitude of AP2 P1G is equal to root under 52 minus 48 cos 90 degree. Cos 90 degree is known to be 0, so this term goes away. So this becomes root under 52. That is, this becomes 2 root 13 meter per second square. This is the required answer. Next we have theta is equal to 120 degree. In that case, AP2 P1G becomes, we are interested in magnitude, not this arrow. Okay. This is root under minus 48 cos 120 degree. Cos 120 degree from trigonometry is minus half. So this becomes root under 52 minus 48 into minus half. So this becomes, this is minus half. Okay. This is root under, this becomes 24 and 52, 76. 48 by 2 becomes 24, 24 plus 52, 76. Okay. So this becomes 4 into 19, so 2 root 19 meter per second square. This is the required answer. Okay. I'll rub this. Okay, fine. And last, theta is given to be 180 degree. Okay. In that case, AP2 P1G becomes root under 48 cos 180 degree. It is well known that cos 180 degree is equal to minus 1. So this becomes root under minus 48 into minus 1. So this becomes 52 plus 48, that is 100. And this becomes 10 meter per second square. This is therefore the required answer. So this was the numerical just to illustrate the calculation of magnitude of vector A P2 P1G. Okay, this is absolutely clear, I suppose. I'll rub it, okay? Now I'll take up another problem on calculation of relative acceleration, okay? So second example, this is how it goes. P1 and P2 are 2 points which move with respect to ground. P1 and P2 are 2 moving points with respect to ground. P1 and P2 are 2 moving points with respect to ground. P1 and P2 are 2 moving points with respect to ground. P1 moves along positive x-axis at a constant acceleration of 4 meter per second square with respect to ground. Point P2 moves in a first quadrant along the line y equal to x root 3 along increasing x values. Increasing x values with a time dependent acceleration equal to 8t, where t denotes time. This acceleration is also with respect to ground, okay? So 2 things we have to find out. We have to determine 2 things. To find, first thing we have to find, in fact we have to find 3 things. First we have to find the magnitude of relative acceleration of P2 with respect to P1 in ground frame. Magnitude at time t. Okay. Or second we have to find time instant t at which the relative acceleration has a minimum magnitude. Time t at which A P2 P1G has minimum magnitude, has a minimum what? Magnitude. And third, the minimum magnitude of this relative acceleration. Minimum magnitude of this relative acceleration. 3 things we have to determine, okay? First we have to find the magnitude of relative acceleration at time t. Then at what time t this relative acceleration has minimum magnitude, and the minimum magnitude of this relative acceleration, okay? And this relative acceleration is understood to be in ground frame, fine? So I'll write this, okay? 4 and 80. I'll write this. So to solve this problem, what do? We draw the diagram of the situation. We draw the diagram of the situation. Fine. So we draw the diagram. This is the x-axis. This is the y-axis. This is the origin. Point P1 moves along x-axis. P1 with a constant acceleration a1g equal to 4 meter per second square. Constant. P2 moves along this straight line y equal to x root 3. It is known that this is the equation of a. It is known from the theory of coordinate geometry that y is equal to x root 3 is the equation of a straight line in xy plane passing through origin and making an angle of 60 degree with the positive x-axis. So point P2 moves along this straight line. Its direction of acceleration is along positive increasing x value, that means along this direction, not in this way. If acceleration of P2 with respect to ground would have been along this direction, then it would correspond to negative x values, decreasing x values. But here it is clearly mentioned that the magnitude of acceleration of P2 with respect to ground is along increasing x values. That means A to G should be in this direction. Fine. So P2 moves along this straight line with a time dependent acceleration equal to 8t. Okay. And 60 degrees is the angle between these two accelerations. In first part, it has been asked what is the magnitude of relative acceleration of P2 with respect to P1 in ground frame at time t. So that we just now discussed the theory. We took the numerical example in which theta was given to be 5 values. So here A P2 P1g is nothing but root under A1g square plus A2g square minus 2A1g A2g cos of theta. The theta 60 degrees is the angle between these two vectors. Okay. So A1g was given to be 4 meter per second square. A1g square becomes 4 square. A2g is given to be 8t. So 8t whole square minus 2 into 4 into 8t. And theta is the angle between these two accelerations, that is has been explained to be equal to 60 degree. So cos of 60 degree. Fine. So this becomes root under 16 plus 64t square minus 32t into 2 into cos 60 degree, which is half. 2 to cancel out. So this is the answer. 16 plus 64t square minus 32t. This is the answer to the first part of the question. Fine. Now we have been asked to find out what t this has a minimum magnitude. So when A P2 P1G is minimum, will imply that magnitude of A P2 P1G square is also minimum. That means 16 plus 64t square minus 32t is also minimum, which means, why have you taken the square? Just to avoid the calculation, just to get rid of this square root, okay, just to minimize the time saving calculation, minimization problem, okay, calculus. This will mean minimum if derivative of this with respect to t is 0. So d by dt of 16 plus 64t square minus 32 is equal to 0. Now we differentiate it using the usual rules of differential calculus. D by dt of 16 becomes 0, constant, and d by dt of 64t square becomes 128t, and d by dt of 32t becomes 32, that is 0. So t becomes 32 by 128, that is 1 by 4 second. This is the answer to the third part of the question. Fine. Okay. So at t barabar 1/4 second, the relative acceleration between P2 and P1 in ground frame will have the minimum magnitude. Fine. And last, we have been asked to find out the minimum value of this relative acceleration. For that, we put the value of t in this expression. So A P2 P1 G minimum value MIN. MIN meaning minimum. Okay. I've drawn the bracket and bottom right hand corner I've written MIN. So this will become equal to root under 16 plus 64 1/4 the square minus 32 into 1/4. This becomes equal to 16 plus 64/4 square becomes 64/16. 64/16 is nothing but 4. Minus 32/4 becomes 8. So 16 plus 4 becomes 20 minus 8, 12. 12 becomes 4 into 3, 2 root 3. 2 root 3 meter per second square is therefore the required answer to the third part of this question. Alright. So just let me confirm that there is no calculation mistake. No? Let's just let me be doubly sure. Okay. 4 square plus 8t square minus 2 into fine. 16 plus 64 t square minus 32 t minus 2 into cos 60 half. Okay, fine. This is the answer to first part of the question. When A P2 P1G is minimum, the square of this is also minimum. That means this is minimum. That means d by dt of this is minimum. That means differentiating using the rules of differential calculus. 0 plus 128t minus 32 is 0. T becomes equal to 1/4 second. At t equal to 1/4 second, A P2 P1G has minimum magnitude. And last we were asked to find out A P2 P1G minimum value. That is equal to root under 16 plus 64 by t square 1/4 square minus 32 into 1/4. This becomes 16 plus 4 minus 8. So 20 minus 8 becomes 12. 12 becomes 2 root 3 meter per second square. This is the answer to the second part of this question. Okay, fine. So in this 22nd video on relative velocity, I have demonstrated how to calculate the relative acceleration between two moving points for different values of theta, and one minimization problem of relative acceleration has also been discussed. Fine. In the next video, we'll take up some more calculations of A relative, okay, AP to P1G, and then we'll pass over to the numerical problems on relative velocity in one dimension. We'll pass over to the numerical problems on relative velocity in one dimension, okay. So we'll close it just now. Fine. I'll close it, okay. We'll continue in the 23rd next sessions, okay. Fine.